Okay, index laws. So, index laws, we've done ages and ages, and we're particularly talking about indices and the laws that we can use to do them. Okay, so we know that an expression, a to the power of n, okay, is a power, okay, and the a is the base, and the n is called the index. Okay, so just a bit of nice, easy, a little bit of information for us. So say we had 2 to the power of 3, okay, is a power with base 2 and index 3. Okay, so for any number a, okay, we get a to the power of 1 is just equal to a, and a to the power of 2 is equal to a times a, and then a to the power of 3 is equal to so on and so forth. So a to the power of n in general is equal to a times a times a, and we're going to multiply it by a, and we're going to do that n times, okay? So, just the number that's there is how many times we do it, okay? So the actual index laws themselves, okay? So to multiply a power with the same base, what we're going to do is add the indices. So let's say multiplying powers. Okay, to multiply powers, so a to the power of m times a to the power of n, they have the same base, so that would be the same as a to the m plus n, okay? And to divide, so dividing powers, okay, to divide powers, it's a to the m divided by a to the n is equal to a to m minus n. Okay, or alternatively, a to the m over a to the n is just equal to a to the m minus n. So fraction is just division. Okay, power of a power. So if we have a to the power of m to the power of n, then that is just the same as having the product of the two there. Okay. Now, power of a product is a little bit different, okay? So power of a product is like saying ab to the power of n, okay? This just turns into a to the power of n times b to the power of n, okay? So an example of that, if we have, 14 to the power of 2, well, that's the same as 7 to the power of 2 times 2 to the power of 2, okay? Makes it a bit easier to solve than 14 to the power of 2. Okay, and then, of course, we have power of a quotient. Okay, so power of a quotient. So a quotient being like a fraction or a division, a divisor. So this is just a to the n over b to the n as well, okay? So these are all our index rules and index laws, and consequent rules that come about from those laws. Okay, so let's have a look at some of these in an example. So we're going to use index laws to simplify the following expressions. Okay, so nothing too hard. So let's start with a. So x to the power of 4 times x to the power of 7. Well, that's just the same as x to not a, as x to the power of 4 plus 7, okay, which is just x to the power of 11. Now, you wouldn't be required to do all of that working out. You could just go from a to the power of 4 times a to the power of 7 is equal to a to 11, but for the sakes of this, I was just showing you how it is done otherwise. Okay, b, we've got a to the 2x times a to the 3x. So nothing's going to change here. We're still going to add the powers because we have the same base. So it comes a to the 2x plus 3x, so it's just a to the power of 5x. Okay, that's our answer for that one. Now c is w to the 16 divided by w to the 8. Well, it's just w to the 16 divided by 8. Well, not divided by, sorry. So when we dividing powers, we're going to subtract them. So it's w to the power of 8. Okay, and that's my answer for that one. Okay, I'm going to move back up here for these last three. So D. Now D is a little bit trickier. We've got 8 to the power of 7b minus 3a divided by, and it's 8 to the 6a minus 2b. Now, because we're dividing them, it's going to do the same thing as per normal, and we're just going to subtract the power. So this becomes 8 to the power of 7b minus 3a minus 6a minus 2b. Now, the reason I'm putting them in brackets is because when I subtract, okay, I'm subtracting all of the second one, so it's going to be 6a plus 2b. So this is 8 is equal, this is equal to 8 to the power of, so 7b plus 2b is 9b, minus 3a minus 6a is minus 9a, okay? And that's that one. Now we've got a power of a power, so t to the power of 6 to the power of 5, well that's just the same as t to the power of 6 times 5, okay, because it's t to the power of 6 times t to the power of 6, and it's 5 times, so that's just the same as t to the power of 30, okay, for that last one. And for F, the final one for this example, we've got 2 to the power of 3x, lots of 6yz, okay. So to solve this one, same thing, we're going to just multiply the powers. So 3x times 6yz, and that gives us 2 to the power of 18 xyz, okay. And that's our final answer. Now, with that, we're going to have a look at a second example and the third one as well. So some tougher expressions in this case. Okay, we've got to expand the brackets in each expression. So we'll start off with A. Okay, so we've got 2k to the power of 8, lots of 4, over 6k to the power of 3 to the power of 3. I just like writing out the questions again. It's just a personal habit of mine. Okay, let's expand this one out. So we've got a product of a product, power of a product. So it's 2 to the power of 4 times k to the power of 8 times 4 over 6 to the power of 3 times k to the power of 3 times 3. Okay. Continuing on, 2 to the power of 4, well it's 2, 4, 8, 16, so we get 16 k to the power of 8, 16, 24, 32. Okay, divided by 6 to the power of 3 is 36. Too hard for me, so I'm going to use my calculator. So 6 cubed equals 216. Okay, and that's k to the power of 9. Now, we're not actually done with this one yet. We can continue making it smaller. So we can find the highest common factor. I can just put my fraction straight in. 16 over 216, see what it simplifies to. So it's 2 lots of k to the power of something over 27. Now I know that k is going to be on top because we've got 32 on the top and only 9 on the bottom. 32 minus 9 is 23. So it's going to be 2k to 23 over 27. That's our final answer. Okay, continuing on, we're going to do part B. Now we have 5xy to the 9, okay, over x to the 8 times, I'm not going to worry about times, y to the 3 all cubed, okay. So this is the same as 5xy to the 9 all cubed over x to the power of 8, y to the power of 3 all cubed as well, using that power and quotient rule. Okay, 5 to the power of 3 is 125. Okay, x cubed, y to the power of 9 to the power of 3 is just y to the power of 27. So we'll write y to the power of 27 over x to the power of 8 to the power of 3 is x to the power of 24, and y to the power of 9. So now simplifying this one, okay, so 125 is going to stay on top. Now the x's will be moved to the bottom and the y's will be moved to the top. So y to the power of 18 on top and x to the power of 21 on the bottom. Okay, and that gives us our expression for that one. So we've got A and we've got B over there. Okay, And we'll have a look at one more example. Okay, so, well, no, not yet. Okay, I'm going to finish it there for this video. We'll look at those examples in another one when we do the negative indices.